Hello. Hi, everybody. Welcome to the latest edition of the NYU Game Center's lecture series. Thank you all for being here tonight. And before I introduce our esteemed guest, I'd also like to thank a couple of the sponsors that make this series of events possible, Take-Two Interactive and Empire State Development. Thank you for helping out folks at those organizations. So it's my pleasure tonight to introduce someone who I originally met during a time when there was something that was being dubbed probably more as a marketing label or a keyword tag that you could put on these sites that used to exist called gaming journalism websites that no longer exist. There was a thing that was dubbed queer games that existed. And it was really just a whole bunch of people making games with all sorts of tools. And one of the things that made it interesting was that suddenly it was possible for more people to make games than ever before because of the advent of various types of tools and game making engines that were easier to use than trying to code stuff from scratch. And so we saw a lot of really interesting narrative experiments in that time, a lot of things being made with tools like Twine. And some of them I thought, that really stood out to me because they were doing something interesting with game design. Some of them stood out through strength of storytelling, but there was one person's work who I was like, whoa, this person is not only a storyteller, not only kind of a master crafter of relationships and characters, but also is clearly a very good programmer. And that was Christine Love. Christine Love once, as part of a breakup, made the most technically complex Twine game that I've ever seen in my life that includes a real-time action gameplay in Twine, right? So people are like, oh, Twine, that's really easy to make a game Twine, as if that were a bad thing, but sort of poo-pooing and being like, well, this is like, easy stuff. You can make a game in a week. But did you know you can make a first-person shooter in Twine? Christine Love did it. And it was, lest we forget, it was part of a breakup. That's also important to mention as part of the story there. But it doesn't really end there. Christine Love has also achieved notoriety in that time for making games that had achievements that were impossible to obtain, which angered a whole generation of gamers. I don't think we can really say, not the same type of gamers that then became angry during Gamergate, but like a whole different set of gamers that were like, why can't I get this achievement? I don't think Christine will tell you the story of that achievement tonight because there are other more important, more recent things to talk about. But I just wanted to tell you a little bit about why I've, over several years, slowly managed to drag Christine down here across the border, which, if you haven't heard, has gotten increasingly a disturbing border lately. So we're very grateful that she crossed over to be here after me trying to get her here for a couple years. But I will let her talk to you about what she's been up to lately in this talk called Lily Engine and Building Your Own Engine. Please give it up for Christine Love.
Thank you, Naomi. I don't think I really need to explain anything else personal about me now. You've really just borne my entire soul. But my name is Christine Love. I co-founded an indie studio called Love Conquers All Games. And over the past 13 years, ridiculous amount of time, we've released 4 commercial narrative games, none of which were about a breakup of my own. Including the lesbian road trip RPG, Get in the Car Loser, my most recent, and the erotic romantic comedy, Ladykiller in a Bind. A lot of our games are built around doing, as you said, interesting experimental stuff with narrative. Our first game, Analog A Hate Story, was an early, what I call a document search game, sort of puzzles based around reading documents. And Ladykiller had an experimental dialogue system that won it the IGF for narrative back in 2017, also an absurd amount of time ago now. And I assume all this is why I was invited to talk today. Unfortunately, I'm not talking about any of that. I'm not talking about narrative. I'm not talking about games about breakups. I'm not No. I'd love nothing more in this world if I could just talk about game design in the abstract and focus entirely on trying out, narrative ideas and new mechanics. Unfortunately, in addition to being a writer and game designer, I'm also my studio's programmer. So instead, I'm going to talk about what I'm working on right now, which is building our own internal game engine. It's called Lily Engine. I'm really excited about it. And every time I say I'm working on a game engine of my own right now, everyone looks at me like I'm crazy. So I'm here to convince you otherwise. But conventional wisdom goes something like this. If you want to make a game using someone else's game engine, you'll spend all your time making a game. If you want to make a game using your own game engine, you'll spend all your time making a game engine. And, I've seen a lot of people do this, and I think this is generally correct, actually. For 90% of people, making your own game engine is a bad idea that will get in the way of what you really want to be doing. But I think 90% of people don't do this. But if you're not sure if you're in that 10% or not, I'm going to talk about why it might be either a good idea or a bad idea to build your own game engine. I'm going to go into some detail about the difficulties we've experienced while working with other people's technologies. And then, because I've seen a couple years ago, GDC, other events, I've seen people do this kind of talk before. And I think everyone gets really excited about, their own technology, and they get a little too vague, and they get really fired up on, the idea of controlling your own technology and the ownership of it in the abstract, but they don't get into really specific stuff. So I'm going to get into some really specific technical details because I love technical details, and I'm going to tell you about some really gritty stuff I've experienced over the course of the development of Lily Engine. Some of these issues will be universal to any engine, and some are such specific bullshit that will never come up for anyone else in a million years, but I'm hoping I can give us just a sense of what sorts of problems you'll encounter. And then finally, after all that, I'll talk a little bit about how abstractly cool it is to have control of your own engine. So first off, what actually is a game engine? Wikipedia describes a game engine as a word used to describe a transgression against the gods, provoking divine No, okay, fine. What it actually says is a software framework primarily designed for the development of video games that includes relevant libraries. That's actually even more vague than my joke. Okay, never mind. Let's come back to this later. Let me talk about the actual experience of working with a game engine, and we can work backwards from there. As a studio, Love Conquers All Games, we've shipped games using two engines, Ren'Py and Unity. As Naomi said, I've also worked personally with Twine. I've also worked personally with GameMaker, but I'm just going to talk about these two today. I describe my experience with Ren'Py and Unity as quite different. Our first three games were primarily visual novels with interesting mechanical twists. We have Analog and Hate Plus, which are document search puzzle games about reading diary entries and picking which ones to discuss with your AI companion in visual novel sequences that unlock further documents that help you solve a mystery. Ladykiller in a Bind, it's about juggling suspicion points and votes in a game of social manipulation where you pick which scenes you want to see based on, balancing risk versus reward, with a unique dialogue system where choices appear on screen as they occur to the character, then disappear as they're no longer relevant to the conversation. So you have to pick when the right moment is, or the moment passes and you can't get your stairway wit comment in anymore. These are both basically visual novels, but they have some pretty big mechanical twists. We built all three of these in Ren'Py. Ren'Py is an engine designed specifically for making visual novels that primarily uses Python, as well as an internal screen language for designing UIs that feels like what if HTML used Python syntax, basically. As far as engines goes, it's extremely opinionated. It makes it very easy to make conventional visual novels, and it definitely expects that's what you're doing. The main way you interact with the engine is through writing script files that look like this. This is directly from Ladykiller. I picked the first fragment that had the word fuck in it. But it's it's highly legible. It looks like a script, even though you got these bits of code that might be a little mysterious, but it's generally driven by these script files. It represents stuff like in-game dialogue, character expression changes, audio cues, calling menus. It's quite extensible and lets you do some pretty powerful customizations. Hence how we're able to use it to build our experimental document search games, which have, like a bunch of screens for reading like diary entries and letters and family trees and stuff. It also lets you add custom statements to your script, which was necessary for Ladykiller's unusual dialogue system. But still, it's quite opinionated. It has a lot of built-in features like displaying text-type dialogue, click to continue, saving and loading, rollback, preferences menus, and expects all games to use all these features. That's not really a bad thing. By being opinionated, it means you can work within its expectations. And if you work within the engine's expectations, it won't fight you. An opinionated engine means that you can feel confident that you're doing things the right way. It also means that if you step outside of what it's good at, well, it'll be hard and some things will be impossible. But you'll at least know that you're doing something that your engine's bad at, which is really useful knowledge. I like RenPy. I think it's a great engine. In the past few years, it even updated to Python 3, which is a great language to work with, a lot of great features, even easier to use. We moved away from it because it's just not well suited for the kinds of games we want to make. But it's very good at making the kinds of games it's good at making. For our most recent video game, Get in the Car Loser, we switched to Unity. Get in the Car is a more traditional type of game. I usually describe it as a video game-ass video game. You play it using a controller. There's a console port. It's got complicated real-time battles, bits where you walk around and talk to people. It's got visual novel conversations. There's a lot of different aspects to it, like just a bunch of different modes of gameplay. So we built it in Unity. If you have the misfortune of following me on social media, you've probably seen me express a lot of different, very emotional opinions on the experience of working with Unity. So let me, for once in my life, be calm and measured. I just described how RenPy is extremely opinionated, but it limits the type of game you can develop in. Well, Unity is basically the opposite approach. You can make literally any type of game in Unity. 2D pixel art RPGs, 3D walking simulators, action games, puzzle games, whatever. It has no restrictions because it's not opinionated on how you should use it. Part of why it's not opinionated is because it was created by a team that made one game back in 2005 and spent the following 20 years building an engine in a bubble with no internal game development projects. So all of Unity's tooling and features are made from a sort of abstract position of just trying to guess what users might want, but not actually informed by direct game development experience. Furthermore, Unity's lack of opinionation extends even to basic features. There are often many different ways of doing the same thing in Unity, and it's not immediately clear which is correct. There's multiple rendering pipelines. There's multiple ways of displaying 2D objects on screen. There's multiple text renderers, one of which you have to install from like the package manager, but it is like officially supported, and it's in a different documentation system from the other text renderer. There's multiple ways of loading assets. I think by the time I finish this paragraph, there's probably another rendering pipeline now. If you want to do things like handling, saving, loading, triggering audio, typing out text and dialogue, you have to implement these things all yourself in C#, and they give you enough of a tool set that you can do this. But you lose out on the biggest advantage of an opinionated engine, which is that it's telling you the right way to do things. In Unity, there's generally no right way. And in practice, Unity development generally looks like you building enough scaffolding in C# that you don't have to interact with Unity's APIs very often, eventually. After 4 years of development of Get in the Car, the conclusion that I reached was that I was not actually saving much time using Unity because it had all the disadvantages of requiring you to build all your own scaffolding for basic features, but also all the disadvantages of having to work around weird quirks and things that the engine is simply bad at handling anyway. If I was going to spend this entire talk just discussing problems I had with Unity, I'd be here all day. We don't have that much time, but let me offer two concrete examples of engine features where Unity was quite time-consuming. First off, I describe its UI system as quite baroque in comparison to the really clean-looking RenPy one. I sort of gained a new appreciation for why a lot of games built in Unity don't emphasize UI, don't have like super polished menus. It's because it takes forever. Unfortunately, Get in the Car Loser is an RPG, and RPGs are basically menu games. So it means, well, it was a lot more work. Instead of a markup language, you have to build your UIs using this GUI. I tried to get a screenshot that like included as much information on screen as possible, and it's just kind of hard to do that. Like there's all these like nodes that like you can only see the information if you click through to them, and all these correspond to C# that you drive underneath to actually like include stuff, and it's the way that this works is just it's really fiddly and hard to work with. There's also stuff like the layout engine, like the text layouts, the element layouts, like just like what order objects render in, and like when should you wrap the line. It's quite slow, so whenever you adjust text in the UI, it takes a whole frame for the text layout to change, and one frame doesn't sound like a lot until you realize that like, you load a menu, then the text loads in a frame later, and you always see this big jump. So you have to work around that in order to like compensate for these very slow layouts. It's also incapable of like you can't all these things have names, but they're actually you can't refer to them by name in code because it's too slow for that. So instead you have to like be like, I'm going to address text field number 3, text field number 4. But if you have 5 text fields on an object and like you put one on top of everything else, then suddenly all your indexes change. So you have to go from that and reorder everything and make sure you've changed every reference to an index by hand because there's just no system for doing this automatically. And like there's ways of working around these problems to an extent, some of which are acceptable, some of which are just kind of always a pain in the ass, but the end result is that you are spending a lot of time doing UI implementation. And the more time you spend on UI implementation, the less time you have to iterate. I had like a bunch of estimates for how long like UI screens would take based on my experience working in RenPy, and all of them took like 7 to 10 times as long. I'd be like, oh, this is like a couple hours. No, this was 2 weeks of work. And like if you do a screen that's like, I don't know, like it's normal in an iterative process to start with something that is a little bit confusing, but it's got all the information there, and then as you look at it more, you like change it and polish it, and eventually throw out the whole thing and put in a new screen in this place that actually like works good. And if that takes if that's gone from it takes an hour to it takes 2 weeks, you're just doing less iteration. And like, for an RPG, like menus matter. So your game design also suffers as a result of not having this iteration time. I'd say a good engine is one that makes it easy to iterate. Okay, here's another example of what I would describe as a fairly typical Unity bug. I'm not telling you about this one because I'm secretly insanely mad about it or anything. It's just genuinely, this is normal. Okay, so I wrote a system for loading sprite sheet animations using Unity's Addressables API, which is, I think, their 3rd way of loading assets. It's the currently recommended one. The others are kind of deprecated. Then at some point during the console porting process, I was forced to update from Unity 2019 to Unity 2022, and suddenly every animation in the game was playing in not only the wrong order, but like just like showing random frames in like a random order. After a lot of digging, this behavior change was not documented. It wasn't in any kind of changelog. It turns out that the Addressables API used to return all your sub images of a sprite sheet in order, but the documentation didn't guarantee they'd do this, so they felt okay with changing it in this update. And suddenly, the API now suddenly started returning your sub images in a random order that would even include duplicates in there. I don't, how is that possible? Anyway, as far as I can tell, the only posts on the internet acknowledging this are a blog post that I made explaining how to wrap your API call to sort and deduplicate things, and also this one Unity forum post asking for help that they didn't then. I cut it off at at Unity asking, but the person responded and they got no follow-up. They got a actually no sorry they got the post saying it works on my end. Can you give us Can you give us more information? To get more information, nothing. Radio silence. As far as I can tell, this bug's still in there. But this is the reality of working with complex and poorly documented frameworks like Unity. You have to avoid updating as much as possible and version lock as early as possible because each version will subtly change things. This bug was easy to catch because it impacted literally everything. But more subtle bugs can be introduced in production if you're later in development. So you really don't want to update, like, unless you have to. It was based off this kind of experience that I decided that building our own engine could not possibly create more work. I do want to be clear here. I'm not an expert on this subject. I'm not actually a good programmer at all. I'm just a game designer who's learned enough about programming over the years, because shipping games requires you to know a lot about programming, but like, I'm not a software engineer. I didn't study computer science in university or anything like that. I studied English literature in university. They don't teach you anything about programming there. I've got 12 years of experience running Love Conquers All games, but like, lasting 12 years making indie games just means that I've made all the mistakes in the red dots here, the ones that don't stop the plane from flying home. And I haven't made any of the mistakes that are fatal. So it's possible that I'm about to do that right now. It's possible that I'm about to make a bunch of huge mistakes in Lily Engine. But I can definitely tell you which parts of working with other people's technologies were mistakes. And I think having that much experience gives me just a clear idea of what sorts of problems we commonly experience during the game development process, and what sorts of things it would be good if we could use technology to make easier. I don't think what I'm going to be saying is useful advice if you don't have a very, very clear vision of what your game development process should look like, and like what sorts of games you want to commit to making long term. I would not recommend building an engine for your first game. Please don't do that. But after 12 years, say, if you're experiencing the same sorts of problems over and over again, maybe it's a good idea to find technological solutions to those problems so you can save time and focus on the important parts of development instead. Okay, so let me finally get back to the big question. What actually is a game engine? When people joke about building a game engine being an act of hubris, it's because, we're thinking about it like you're reinventing the wheel. You were personally unsatisfied with something that does basically what you want to do, so you thought, I can do that better. It's the idea that if you build something from scratch, it's going to take forever, and you're going to be spending all your time recreating other people's work. But I think you should instead look at it this way. Everything in game development, and like programming in general, exists on a spectrum from high level to low level. High level technologies provide more abstractions for you to work within, simplifying the things that you have to worry about. Lower level technologies provide more flexibility at the cost of requiring you to implement more things yourself. At the top of this list are technologies like RPG Maker and Twine, which are built nearly entirely in UI systems, and they want you to fit within very specific structures, make very specific types of games, and the tools are all built around you do this one thing. And at the bottom of this list is, assembly language, the simplest kind of programming language where all your commands basically more or less correspond cleanly to actual processor opcodes, like interpreted by the CPU. I have a total tangent here. Honestly, I think learning assembly is kind of fun. I think you should I think everyone who programs at all should just try it once. I found this really great tutorial that has in browser assembler, and it just sort of walks you through doing some basic steps. I think it's just it's really good to know what's the lowest possible abstraction level before I'm actually writing machine opcodes by hand, just so you understand what it is a computer is actually doing. And then once you have a sense of that, it makes a lot more sense when you're looking at stuff at higher abstraction levels too. It just a lot of the stuff that people were doing in assembly back in the day was quite complex and quite hard to follow, but the actual fundamentals of tell a processor, take this number, move it into this register, add a number, pull it back. That's really simple, and everything just fundamentally compiles down to that. So I don't know, it's cool. I think it's great to demystify what are the complexity of programming, and then never actually do anything in it. Everything else lies somewhere in the middle of this this axis. RenPy, it's very high level. Unity is also high level, but so are the technologies that they use. Python's a high-level programming language. C#'s a high-level programming language too. C++, a lot lower down this list. C is close to the bottom. You can evaluate the libraries being used in your in your technologies as well this way. SDL is a very low-level C library that gives you a lot of primitives for handling stuff like input or video abstractly, but it doesn't offer opinions on how you should use them. Fmod is a very high-level library that you invoke with a few C DLL calls, and then it just handles everything else as a black box in your code that just sort of magically works on bank files that the musician creates in their GUI. Everything in software development exists somewhere on this axis. If you're creating a program from scratch, well, in 1991, it probably meant you were writing raw ASM, but like today, you can be using high-level languages, working with low-level libraries, whatever. So let me propose a better definition of a game engine. A game engine is just a set of familiar technologies used to make multiple games. I mean, it has to be multiple games or it's just a bespoke game made from scratch, right? It's not a framework if it's not reused. But there's a lot of advantages to those familiar technologies being very familiar. There's a billion programmers out there with the Unity experience that you can hire to work on your project, a billion Unreal programmers, whatever. If you're working with an artist who has experience with Unity, they don't need to relearn the technology. They can just jump right into implementation. But this familiarity also extends to technologies underlying as well. A lot of knowing how to program in Unity, it just means you know C#. Well, you can just build your own engine in C#. Actually, I like C# enough that I decided to keep working with it, even though my experience learning it was mediated entirely through Unity. It's just that good. But my point is that while your engine might be unfamiliar to those that you're working with, that's not necessarily true of the underlying technologies you're using. You can build a better engine using stable and well-documented libraries that do a better job at doing one thing very well than off-the-shelf game engines do at trying to provide universal solutions for everyone. The whole point of building an engine to me is to reduce the amount of time you spend doing actual programming. I think programming is the worst part of developing games by a very long shot. It's the thing that interferes with you making like design decisions, narrative decisions, seeing your art get implemented in an interactive way. It's the thing that increases your iteration time. When I talk about building an engine, I'm talking about it from this perspective. I think it can be good to do a little bit of extra work in advance if it means you have to do a lot less work later. I want to be doing as little programming as possible. And because I know what my goals are, I can create very specific abstractions that are catered precisely to the types of games that I want to make. If you actually want to spend time programming, I don't think any of this advice is going to be very helpful. I said before that conventional wisdom is if you want to make a game using someone else's game engine, you'll spend all your time making a game. If you want to make a game using your own game engine, you'll spend all your time making a game engine. Personally, I want to spend as little time as possible making a game engine, so I have more time in the future to spend making games. If the idea of making a game engine excites you, and this excites a lot of people, if you like dealing with tough programming challenges, well, you don't need to worry about it then. You can just have fun with that, but for everyone else, I want to talk about building an engine in a way that reduces the amount of time you're programming and increases the amount of time you get to spend actually making games. Okay, I promised specifics, so let's get into some really technical specifics here. Lily Engine is the name of the engine that I've been working on. It's built on the following technologies. On a high level, everything is driven by C#. Our graphics rendering currently goes through FNA, but most of the libraries we're using are just C# bindings for C libraries. For example, our audio uses C# bindings for Fmod. Our input handling system bypasses FNA entirely just to use SDL2's C# bindings on its event handler. For dialogue scripts, we use the native C# version of Ink. Because we're in C#, we have access to XUnit for doing testing. It's not really useful for things involving player input, but it's great for testing stuff in like turn-based RPG battle balance. Finally, because UI is the most absolutely important thing when you're making games that are basically all menus, we're using a commercial UI middleware engine. I'm not going to name it right now because we're still evaluating and I can't like vouch that like it's going to be perfect, but so far I'm pretty excited. It's available as a C++ library, so we had to write a layer of C++ around that just so we could expose it via C interfaces. Just a quick aside. The way that like accessing libraries in C# works is that you can have ones that are written in C#. Those are really easy. You just import the C# DLL, which is a file that ends with DLL, but it's actually a different type of assembly entirely. It's just like a .NET format. Anyway, that's super easy to import. If your library is written in C, but it does have C# bindings provided, You can import those C# bindings, but often the APIs will be written in a way that like you still have to deal with stuff like C pointers, which you can do in C#. This really surprised me. This is valid C#. That's like C arrow operator to dereference something. That's you're not supposed to be like touching memory directly in C#, but some of these C libraries kind of expect you to, and that's fine. You wrap it in an unsafe block. You make it as little stuff touch as possible. It works fine. This is accessed by SDL. It's passing in the right thing. I can trust it. Furthermore, if you're using a library that's written in C++, a lot are. This middleware library was. Steamworks is written in C++. There's also a thing called pinvoke, which just lets you access C methods directly from C#. All you do is just add this one line in front of your function call, and that tells .NET that actually this is find this in a library somewhere. It'll follow this this signature. The one thing is that C++ objects can't actually cross that boundary. It's only for C. So in your C++, you'll have to have like an extern C method that's saying this is C, and like just C++ objects can't pass that boundary. But it's fine. You just write C interfaces. Anyway, I was talking about our UI engine. What I really like about it is that it uses actual HTML, which is really easy to write, and it's very, very well documented. There's so much good documentation about HTML out there. And it means that we can actually use like really, really high-level web technologies for our UI, like React. This is actually the part I've been most excited about. UI iteration time in RenPy was very fast because of its HTML-like qualities, but it ended up being a little hard to refactor to be easily modifiable because it's not that robust. Like, it's good. It's just not like the entirety of web development has been finally honing this over decades. Meanwhile, UI in Unity means bouncing between GUI and C# using weird and non-documented primitives that are half-deprecated. And the things that I expect to take 2 hours to mock up in RenPy, they take a week or two, which is, again, brutal for your iteration time. But doing UI in React has been great in comparison. And one of the biggest advantages that React in general, TypeScript, HTML, they're all very well documented. So you spend less time groping in the dark, and you just have a lot more access to the very wide range of web development resources out there. This does mean that we're using like a lot of very disparate technologies. There's like, I think my count is like 5 different programming languages used in the entirety of the project. C# mostly. There's C++ for the UI engine wrapper. TypeScript, React, CSS. I'm all lumping those all together as one, although it's not. Ink for scripting, GLSL for shaders. But this isn't really that different from the number of different formats that specialized engines use. They're just not usually well-documented standards. It does mean that we have to be very deliberate about separation concerns and how different components interface with each other. But also, it's actually a little bit easier to have strong separation concerns when being in different languages means that everything has to go through these discrete interfaces to go from one language to another anyway, which is kind of funny. One good thing about using a number of programming languages is that you can just work with the language that's best for the problem you're dealing with. Like, nearly everything I've talked about has been C libraries, and yeah, I could just solve this problem by writing the entire engine in C++ instead, but I don't know. I don't want to write C++ all day. We considered Unreal and did like a little bit of prototyping in it, and actually getting my hands dirty with C++ was a great reminder that I think I would go insane if I was dealing with C++ every day. Like, it's fine if I have a single component in there that I have to modify occasionally, but I'm not good at dealing with C++. Like, it's just hard and complicated. I didn't study this shit in school. I can't imagine having to do like explicit memory management. I think that would cut into iteration time a lot. I'd rather just lean on all the abstractions that C# gives you, except for writing UI, because it's easier to do that React and CSS than C#. But my point is, the thing you're doing, the bulk of the work in, should be easy to work with. I think it's important to think about things from the perspective of what will be taking up most of my time. And one really important thing here is that everything both needs to be, but also can be designed in a modular way. One of the best things about writing your own engine is that you have control of your own technology. But you might be wondering, is that really the case if you're using other people's libraries? I mean, isn't that kind of cheating? But I mean, it actually is kind of true. If you can just swap out a library that isn't working for you and just drop in a new one. For example, right now I'm using FNA, which is a recreation of Microsoft's ancient-ass XNA framework for for working with the Xbox 360. This is so old. They don't support this anymore, but there's so many games written in it that there's community re-implementations of that API, and weirdly, it has insane idiosyncrasies, but honestly, it's kind of good to work with. The FNA community is just really good because it's really well supported. Anyway, we use that right now, but since we only use it for graphics, I'm gonna just replace it with STL GPU at some point. STL GPU being a feature from STL3 that's somewhere in the middle of that high to low level access I showed you before. It's designed to abstract away the specifics of graphics APIs, which is great because I think learning low-level things like the specifics of OpenGL and Vulkan and Metal is exactly where people get lost in the sauce when it comes to implementing engines on their own. That's hard. The graphics APIs are, I mean, for one thing, they're constantly moving target. They're really complex. Vulkan's supposed to be, more powerful and easier than OpenGL in some ways, and impossible for a human to actually look at in others. And I'm simply a mere mortal. I can't work with graphics APIs directly. Anyway, I'm gonna run through a bunch of insanely specific problems we had while working on Lily Engine and how we solved them. You will never encounter these particular issues specifically, but you'll absolutely encounter weird stuff like them. This is the scope of the problems that you'll have to be encountering if you're building your own engine. So I've been using Visual Studio Code for a minute, not Visual Studio, Visual Studio Code, the multi-platform version. It's really good, actually. I used to really hate IDEs passionately, but VS Code is it runs pretty well. I don't know. Maybe I'm showing my age here, but I used to I remember back when Eclipse was the standard for Java, and yeah, just typing text shouldn't cause hitches in your text editor, but that's not the case now. VS Code's great. It's got a lot of great features. I use show references to classes and variables constantly. I think I'd code 10 times slower without that. It's also convenient because it means even on a Mac, I can stay in the Microsoft.NET ecosystem, which is okay. I think Microsoft's whole programming ecosystem has really weird vibes. If you're used to open source, it's just weird. It's just weird and corporate. Everything is define 12 layers of XML nodes to implement an information provider handler node reference or something. It's just culturally from a totally different planet. Redmond. But still, if you're working with C#, there's a lot of benefits to using MS Build, despite what the build files look like. So we're still using it even as the configuration files look like. Sorry, I'm just looking at this again. These are some really awful XML blocks. I hate these. But, okay, anyway, I mentioned we have a ton of different programming languages involved, right? So here's how it works. We have a CS proj file, that's the C# project for the actual game. In this case, the example project here is called Angelic Sadistic. And that references the Lily Engine's CS proj. The Lily Engine CS proj then references the CS proj for our C# middleware wrapper for the UI, as well as handling copying various libraries that we get in DLL and dilib formats, like Inc, which is a C# DLL, fmod, which is a native dynamic library. That C# UI middleware wrapper, unfortunately, then it has to call CMake, because in order to use the C++ library in C#, you have to write C++ that provides C externs to pinvoke into, as I mentioned. So that's actually 2 build systems in my build system. Anyway, after CMake finishes doing its thing, it kicks control back all the way up to the original game CS proj, which then calls inculcate, which is Inc's compiler, to compile Inc files into JSON. And then it also runs npm run build to have all the React TypeScript get compiled into HTML and JavaScript to get dumped into the game's resources directory. Finally, once all that's done, MS-Build automatically launches the project. If you haven't modified any C++, which you almost never do, it's not locked in Amber. You can change it, but you don't have to, and you don't often do it. Like, I'd say I touch the C++ side of things maybe like every other month. Anyway, this whole process takes about 3 seconds between hitting the play button in VS Code and the program launching, which is, about how long Unity takes after you press the play button. Is this all a little bit complicated? Yeah. Do I like working with MS-Build and CMake? Some of the... They're awful build syntaxes. I think they're some of the worst build system syntaxes known to man. I don't love that, but also the thing is that all this was a pain in the ass exactly once at the start of the project. And now my interactions with the build system mainly consist of, you have to add an extra line every so often when we import a new library. So the additional complexity doesn't actually make my day-to-day work more difficult. Okay, so the other day I was working on mouse controls for a test game that was mostly designed with a controller in mind. So imagine you've got a menu, this attack menu, where the items change background cover when you hover over them. Then you click on something, and that makes another menu appear on top of it. And your cursor is already on top of that random item in the new menu already. How do you make that count as a natural, hover? Well, we're in HTML, so at first I assumed that was probably like on mouse enter event or something, but it turns out that HTML doesn't trigger that event if the object was spawned around the mouse. It just doesn't count as a mouse entering for some reason. It gets triggered the instant you jiggle the mouse. That triggers the event, but HTML didn't really anticipate that you spawn an element on top of your mouse. Okay, so I spent 2 hours banging my head against this problem trying to figure out a good HTML-y way to handle it. Then I remember, wait, I literally control the input handler. I just went to the input handler, and now we just send an extra mouse move event to the render every frame. And just like that, our new menu item counts as hover the instant it's created. It's great to use technologies where a lot of your problems have well-established solutions that you can find by searching for other people having your problem. It's great if you're using something where you can simply find an answer on Stack Overflow. But also, if you control how your components interface anyway, you can just change your input system to handle that kind of oversight. You don't always have to find a hacky solution that fits into the expected paradigm of the engine if you just control the engine enough to change the way the engine works. So that was pretty exciting. Portability. Like I said, I do most of my work on a MacBook Air because in 2025, I think, honestly, they're best you get. I use Windows for console builds because that's what they require, but I don't really want to be doing work on Windows. Anyway, consoles require compiled code to run. Unity uses something called IL2CPP to convert all your C# code to C++, and it works fine. It works totally fine. FNA uses a more recent Microsoft-developed technology called native AOT that also compiles C# to native code directly. It works on Xbox and Nintendo Switch. This is just me going off their FAQ page. They're still working on a PS5 version. I can't go into further details about my experience with working with native AOT builds just because console development is all under NDA, but it's fine. It's totally fine. I have no complaints. It's a little bit fiddly, but any console porting is fiddly. It's totally fine. So as far as integrating Fmod goes, I blocked out a whole week for this because I'd never worked with it before ever. Their documentations, it's mostly written from a C perspective, and it's a little bit abstract when telling you how to do it. Their C# bindings they're not really idiomatic C#. They're just exposing idiomatic C. So they do stuff like having every function return an enub type called fmod.result that tells you whether it's success or failure. This is normal in C, really weird in C#. You'd rather have exceptions. Anyway, loading the fmod library takes 3 lines of code, and then you're done. It's insanely simple. And because this is C#, I just wrote an extension method on the fmod result type. It just throws an exception if the result isn't fmod.ok. And it puts a failing result in the exception body. Then you write some wrapper methods that all your fmod calls go through, and have everything in those wrapper methods call this .checkResult method on every fmod API call, and boom, you're done. It was 2 days work all told, despite the fact that they made me roll my own error handler code. I mean, they're expecting C users. This is just an ancient idiom. It's totally normal to do this in C, which is why I don't want to be working C. This was still the easiest library integration I've ever done in my life. It took a day and a half. text typing. This is really important. You know, like you have a line of text that needs to be typed out letter by letter, this effect, until the full line is completed. Depending on your perspective, this is either a very niche feature or here. Let me just run that again. It's either really niche or it's the most basic thing that a video game can do. Every visual novel needs this. Every game that features dialogue should have this, although some don't, and I have so many opinions on what needs to be done in correct text typing, and I've had to independently implement in everything I've ever worked on that wasn't in RenPy. Like, sometimes I kind of wonder, like, how many hours of my life have I spent just implementing the basics of text typing? It's measured in the dozens for sure. I don't want to think about it too much. It might even be dozens to come, but it always requires the same things. It's really important to get right. It's really important to get right if you're spending your entire time in a game reading. The text needs to look good. The most common technique for handling text typing is that you write out the entire line of dialogue with the typed out letters set to fully opaque and the untyped letters set to fully transparent. And over time, you move letters from the transparent section to the opaque section. The reason why you include every letter is because the typesetting depends on you knowing the width of every word. And it's also good to know the full size of the final text box too. It just helps you position it. If you've ever seen a game where like it starts typing and it hits the end of the line and like a word starts typing and then suddenly like juts over to the start of the next line, you've seen a game that's fucked this up. You need to typeset all your words, even if you don't show them. It's a really common mistake. So in Unity, we use rich text tags that have an opaque section of text and a transparent section of text, and it worked totally fine in that render. Super fast, rendered great, looked great. But Lily Engine uses HTML to render text, which is great for a lot of purposes, but in this one case, it turns out that moving letters from one element to another forces a DOM redraw the entire parent element, which is, like, it's not slow, but you don't want to do it 60 times per second. It was a bit of a challenge to figure out how to do this quickly. I tried a bunch of things, splitting every letter itself into different elements that could be individually addressed. That was also slow. It had typesetting issues. What we ultimately had to do was we split each word in the line into a span element. We give them like a right margin to simulate the space between words. We get rid of all the actual spaces and then run a CSS animation on each individual word because CSS animations are actually intended to be quite fast. I then went through like 50 different optimizations on this because it's important this handled like incredibly fast. You need to hit 60 frames a second on this. And there are some CSS animation libraries out there that are like really good for making the syntax a little easier to deal with, but it turns out they're more designed for like you have a website, you want to have like an animation show like on a click, maybe even 2 animations, maybe like really ostentatious, not kicking off an animation for 100 different words at once. But doing raw CSS animation stuff worked fine. It turns out it's simple enough to just write the CSS itself in a constructor in React. It's a few more lines than I'd like, but again, whatever. Initially, I was using a CSS property called cliprect to clip out the untyped part as I typed in, and it looked fine. But I switched to having an animated property on a shader that's applied to each word, and doing visual effects and shaders is like, that's as fast as it gets. It's happening on the GPU. But it also means I could do some cool effects on the letters that get typed in that wouldn't have been possible in another system. Like in Get in the Car's text typing system, it just like every letter just comes in like fully opaque. Like it would type the L, then it would type the E, then it would type the A. But in this, I can do like a cool like little fade. It's a very subtle effect. I don't know if anyone's actually gonna like notice that unless they're really squinting at it. But I don't know. I think a lot of visual effects, like cool visual effects, aren't necessarily noticed. They're just felt. And this enabled that to happen. So like on the one hand, it's the simplest possible thing that a game with text typing in it turned out to be an insane edge case, something that's very difficult to use in our UI framework, where like none of the most like I went to like 10 of the most intuitive solutions and none of them were the correct one, and they'd all inevitably have frame hitches while doing something as simple as like what you're spending the entire game doing. On the other hand, well, this is a problem once, and I've solved it now. I don't know how many dozens more hours I'll have to spend implementing text typing in my life, but not on Lily Engine. I'm done. I'm good. I mentioned before I need to replace our rendering from FNA to SEL GPU. Personally, I don't know how to write OpenGL in Vulkan. I don't know anything about graphics API. Oh, that's not that. Okay, it's a little bit of a lie. I know a little bit about graphics APIs, and they scare me. OpenGL contexts are hell. I don't want to work with them directly. But based on the small number of places that actually touch rendering in our engine, when it comes time to do it, I will just hire someone for 2 to 4 weeks and have them comment their code well enough that I can maintain it. I mean, like, that's the thing, right? You don't have to know how to do everything yourself. You just need to understand how to make the things you don't understand constrained enough that they're reasonable enough to contract people for. If you're making commercial games, like, Get in the Car took 4 years to make. A 4-year project, you can take on an extra program for 2 to 4 weeks. That's a pretty normal investment to make. And if your engine has a strong separation of concerns, you can minimize the amount of complexity that replacing one component has. Making an engine is not about being some kind of hyper-competent super genius that knows everything. I'm making an engine because I want to focus on things I do know. I have a bullet point here labeled asset loading. We haven't actually started working on asset loading yet. It's really complex. So, like, right now, everything just is doing preloads in advance, and that's good enough for testing the stuff I'm working on right now. But here's the thing I'll eventually have to worry about when it comes time to getting asset loading working. Just, you know, it's just a big list of stuff. Like, is this hard? I mean, not really. You kind of have to do this in every engine to some extent. It's hard to bolt on after the fact, so you have to notice the problem in advance. Get in the Car actually has kind of really long load times. I'm not really happy about those. It's like 30 seconds on potentially, which is, I don't know. I don't love that. But in order to fix those, I'd have to completely overhaul like a lot of interlocked dependencies that were sort of baked in very early on in development, which is like an example of a situation where, in general, video games don't have like a really strong concept of technical debt because generally you end up shipping sooner than technical debt would actually be a problem. Like, it's okay to work fast and dirty in a game where the most important thing is hitting your ship deadline next month. In fact, that's like the most important thing in game development. You need to know how to do that. But if you're building an engine, you're building an investment for years, like maybe even a decade or more. So technical debt really matters there. Okay, here's a really fun one. I personally think it's exciting. So in professional software engineering, they've got a concept called unit testing or automated testing that lets them write out scripts for how their code should be tested to make sure it works properly. And then they just run those tests in batches. Like, they click that little play icon. And it takes, you can see the times it takes. Some of these take a few seconds, others take a few milliseconds. But it shows all these green check marks saying, yep, everything's working the way you thought it should. Like, instead of, you know, like, just running the build constantly, going into battle, hitting the same buttons repeatedly, you can just, like, press play and you see all these little green check marks saying, yeah, no, your recent update didn't break anything. Cool. That's crazy to me. That's so cool. Every time I told like a friend of mine who works in professional software engineering that was exciting to have this, she like laughed at me because I guess in corporate environments, I guess writing tests is considered exhausting and overbearing, but they don't have to replay the same battle hundreds of times per week. So I think it's a lot easier to write like simple tests than it is to be rigorous in your constant playtesting. The one problem is that for testing frameworks to work, your code needs to be able to run headlessly, as in without player input and without actually taking the time to render everything on screen, wait for animations to play out, whatever. But if you design things to work that way, it means that you can just write a scripted set of inputs and then have the game automatically run them. It turns out this is actually also really useful for like making enemy AI in battle as well. It can just select its own possible actions and then run the simulator a few steps forward to see if they make the game state, you know, better or worse for it, and then pick the one that makes it better. Here's an example of one of the tests I have in my RPG. We've got an enemy that responds to being attacked by, like, it responds to getting hit by the player in battle by poisoning the player that hit it. Well, one of our automated tests creates a battle with just that enemy in it, simulates one turn where the player attacks it, and then checks the player's poison stacks. Imagine I made a change to the way attacks work elsewhere in the code. Something that has like nothing to do with poison or counters, and suddenly it breaks this ability. Well, now I'll know about it the instant that it breaks. You just keep doing this every time you add a new feature, and suddenly you can feel a lot more confident that if something does break in a way that causes side effects, you'll know about it right away. Also, because this is an RPG, it's also great for balance. You can use this sort of methodology to run different simulations of the game with like different enemy stats, like what's the base HP of a boss, what's the attack damage. Then you run a simulation saying what percentage chance of actions make the player win this boss fight with this stat configuration. And if every possible action makes you win, then it's probably too easy a fight, right? That's why are you even interacting? But if 0% of actions make you win, then it's an impossible one, obviously. Then you can just export these configurations to a CSV file like this one, and then you go, oh, okay, so if I give this boss, say, 14 health, and it does 2 damage, well, there's a 2% chance of winning. That's not a great number, so that's probably not a good set. The 10-10-10 set, 2 damage, 20%. Anyway, the point is you can just brute force this, and you can suddenly see like a huge slice of the possibility space. If you're not sure how changing a stat will affect the balance of the game because like the effects are really complicated, you can just see how it plays out in the simulation. Okay, so is this all actually a good idea? I mean, I've described a lot of technical challenges that I describe as somewhat daunting, but so far none of the ones I've encountered over the course of Lily Engine development have been what I'd be considered to be like a technical quagmire or anything, which is like the real things you'd be worried about avoiding, like something where you're just like spending months on the same problem and it's like, okay, just one more subsystem and I'm good. And I've already experienced tangible benefits to having like such a level of control over the process. You don't need to be reinventing the wheel. You just need to be opinionated on what the game development process should look like. And I mean, if you've shipped a couple of games already, chances are you already are opinionated on that. And you should trust that opinions being more well-informed than you should trust what some manager working at a publicly traded company in San Francisco who's never made a game in their life, working for a company that hasn't released a game since 2005, thinks would make for a cool technical blog post. Of course you know better what it takes to ship a game. I want to reiterate, I'm not like an open source partisan or anything. I'm not opinionated when it comes to technical stuff. I'll use whatever technology it takes to ship a game as easily as possible. My code will impress absolutely nobody. Naomi, if you saw what it looked like, it's not great. I hate clever solutions to problems, and I'm so bad at math that like I'm constantly asking for help with like problems that I know. I'm pretty sure I covered this in like high school algebra and like geometry. There's a dozen different shaders in Get in the Car, and maybe 1 or 2 of them were ones that like I worked on my own without any sort of help. Everything else I needed like, just like, this is how basic arithmetic works. Okay, now I know how to apply it to the visual effect. But the point is that like most of the work being done here is not difficult technical issues. You're primarily doing broad integration decisions on pre-existing libraries. You're not writing everything in Scratch and assembly like it's 1991. You don't need to be a genius programmer. And I mean, if you are a genius programmer with, like an active GitHub account and you contribute open source pull requests and you do advent of code or whatever, building an game engine that's probably something you can do on your own for fun. But if you're a normal English literature dropout like me, we can just hire someone for 2 weeks to handle the really tough specialized stuff. It's fine. The biggest downside is that you'll be creating situations that no one can help you with because like there will be some problems that exist within the bounds of your libraries, and those are well documented, but you'll have issues that exist in the intersections of those integrations. If you have a problem where like, say a texture renders fine in SDL, but then it gets mangled by the time it reaches your UI middleware's texture handler, you're not gonna find like any forum posts talking about this, and you'll have to potentially debug problems that step through multiple programming languages. But I mean, also that's pretty normal for game development. Actually, I mean, there weren't any solutions on that blog post I mentioned about the sprites being handled in the wrong order. So I don't think that's gonna put you ahead. Even if you're working in someone else's engine, if you're using like a mid-abstraction level engine like Unity, Godot, GameMaker, your game will be full scaffolding and systems that are unique to your game anyway. If you need help with the problem, you'll need to be a little bit better at isolating where the problem exists than you do while working with other people's engines. But it's the same process to get it there. And the biggest upside is I haven't finished Lily Engine yet, so right now all I have is optimistic dreams. I could just be crazy. But here's what I think about a lot. I'm a huge fan of Final Fantasy. I especially love the Super Nintendo ones, and the one that I really love is Final Fantasy VI, which is the third game in the series that was produced for the Super Nintendo. If you've never played it, it's a big, epic story about large ensemble cast banding together to prevent the nihilistic clown Kafka from becoming a god destroying the world. You know, standard fantasy stuff, some really cool fantasy character writing, but 2/3 of the way through the game, you have your big confrontation with Kafka, and then he just does destroy the world. Then the rest of the game takes place in what's called the World of Ruin, which is like a post-apocalyptic wasteland with a totally new world map where the whole party gets split up and they have to reunite, but only after going through an incredibly memorable character vignette of how they find meaning in life again after worlds ended. It's absolutely the most memorable part of the game. It's what makes it really special to me, I think, and I think most of the cast wouldn't really just feel quite that like vivid and alive if they didn't have this big dramatic conclusion to their character arcs. If you played Final Fantasy VI, you already know all this already. But here's the crazy part. This wasn't in the original scope of the game. The game was ahead of schedule, so they had extra time, and in that extra time, they put the bet. Yeah, right? That's crazy. A game ahead of schedule? Who's ever heard of that? I've worked on games that have missed their deadlines by years, and that's normal. Months ahead of schedule? How's that possible? Well, I think the reason why it's possible is because this was the third Final Fantasy they made for the Super Nintendo, and all those games are very technically similar. They've got very similar battle mechanics, similar story presentations, similar game design in general. They weren't rebuilding everything from the ground up every single time. I think they were doing, steady iterations on a common technical framework that meant they could simply focus more of their time on adding the things that made the game unique rather than worrying about the common things that go into every game. So I think about this constantly. What kind of iteration could you do if you spent less of your time worrying about the boring technical problems and more time adding in that thing that you only realize halfway through development is going to be the truly memorable part of the game? Of course, this only works if you're in that kind of situation, like if you know exactly what kind of game you're going to be making, not just in the present, but like if you know what kind of games you're going to be spending the next decade making, then this sort of approach becomes possible. It's a big commitment. I don't think it's a good commitment if you're not absolutely sure of what your creative trajectory is going to look like. But for me personally, in the past 10 years, having made visual novels with puzzle elements and an RPG, which, that's not homogenous. Those aren't that similar. I'm definitely not making the same game over and over again. I do still have a very clear sense of, what the common thread between all my games is. In my case, the analysis looks something like this. What do RPGs and visual novels and document search games have in common? Well, they have logic driven by dialogue scripts. They have character sprites that get updated on every line. They have text typing. They have saving and loading and dynamic audio. If I make a new RPG that, say, has card battles in it, and then I make a dating sim where you have to manage character schedules, I'll still have to spend a lot of time developing unique mechanics for those. I'll have to make a battle system from scratch. I'll have to make a scheduler screen, whatever. But what I won't have to do is write a new parser that looks at the ink files that represent the script and parse character expressions to pass on to the character sprite display system. I'll just get to focus on writing quicker. I won't have to worry about how dynamic audio interacts with game saves. I'll have a stable framework for how those things safely interact. I've been talking about how building a game engine isn't just reinventing the wheel, but if you can create an opinionated framework that encompasses the types of games you know you're going to make, you can actually prevent yourself from needing to reinvent the wheel in the future. Building an engine that's good at certain things doesn't mean you're locking yourself out of doing new things in the future. It means you're saving time on the parts of the game that you already know you're going to do every time. I mean, that's true of most game development too. Part of this is simply perspective shift. By thinking about the engine as a thing that you interface with directly, and that you're responsible for maintaining rather than a product that you write scaffolding around your interactions with, you get the advantages of working with an opinionated framework. But it also gives you a lot of safety and stability. You don't have to worry about breaking text rendering because you had to update a holistic singular engine by a major version just to keep up with the console SDK version upgrade, which is what happened to me when I was doing that port and had to go from 2019 to 2022. You can just update the parts that need updates and version lock on parts that are stable and work. You can work with libraries that provide more stable APIs and more comprehensive patch notes. And if part of your framework isn't working, you can just swap it out entirely. Okay, to try and wrap it up, if you're looking for a simple rubric for, is it a good idea to make my own game engine? I don't have that kind of rubric. I'm an expert on making games, but I'm definitely not an expert on making game engines. And I really hope I never become an expert on making game engines. 10 years making games, great. 10 years making game engines, that's probably a bad sign. But I hope this has at least been like a useful perspective on the things that you should be considering if you're thinking about building your own game engine. I just want to emphasize, building a game engine is not the exclusive domain of genius super programmers who want to do everything themselves. There's no need to build your own ladder on your own when you can simply stand on the shoulders of giants. Use libraries that are available to you. Hire experts to write components that require specialized knowledge. Just to do a quick run through again on all the technologies that I'm using in Lily Engine. Built in C#, high-level language, lots of powerful abstractions that allow for integration with lots of libraries. For scripting, I use Ink, a C#-based scripting library used in many commercial games, as well as Sprake, a C# parser library that lets me parse extensions to the Ink syntax. For audio, I built a simple C# wrapper around fmods, C# bindings for C dynamic libraries. For UI, I work in React, which produces HTML output, and then I render those HTML pages using a piece of commercial middleware. For user input and eventually for graphics rendering too, we use SDL, which is a very old and stable C library with C# bindings available. For portability, we use native AOT. For automated testing, we use XUnit. You don't need to reinvent the wheel, but if you build your own bicycle, you can just swap out your wheels for ones that work more smoothly. I don't think that's actually hubris. I think that's just a solid investment. Hubris, after all, is thinking you can do a better job than the gods. Personally, I don't think I can do a better job than the gods. I think I can just do a better job knowing what I need for my games more than anyone else does. Anyway, thank you. I think I have time for questions now.